Alright guys, so today is part 3 of our learning experience for chemical formulas and equations. Now we've talked about chemical formulas, we talked about a chemical equation where we're putting our reactants and products, and then we checked if they were balanced, and now we are going to move into actually balancing those equations. So just as a reminder, that law of conservation of mass is stating that in a chemical reaction, atoms cannot be created or destroyed in a normal chemical reaction or physical transformation. So that means in our chemical equations that we use to represent these reactions, the mass of the reactant atoms has to be equal to the mass of the product atoms. So we're not gaining or losing any atoms or gaining or losing any elements during a chemical reaction. So in this image we have two elements, S plus Fe. There's a chemical reaction because of heat, and we end up with FeS. And if you look at the equation below, we have on our reactant side what we put in, 32 grams plus 56 grams of reactants. If you add those together, that's still 88 grams, which is what we still had in the end product. So the matter can change its form in a chemical reaction, but the mass doesn't change at all. So that's that law of conservation of mass. So in a chemical equation, we're just going to review those parts again. We have the reactant part and the product part. So in the reactant side, we said that those were the things we're putting in, so the ingredients. And then the product side is the stuff that we get out, so the result. So when we look at chemical formulas on both sides of the equation, you want to make sure it's balanced. So we already did that. We've gone through several different examples of looking at chemical equations and identifying if they're balanced. So when we're doing this, we want to check and make sure we're not losing or gaining any atoms after a chemical reaction because of that law of conservation of mass. So here's a chemical equation example. We're going to go through the process of checking if it's balanced or not. So when we do that, we look at our reactant side, so orange, what we're putting in. Identify your elements and pull them out. So I have C, H, and O. And then we're going to count our atoms using our subscripts and coefficients. So I don't see in CH4, we don't have any coefficients, so we're just going to apply what we see. For C, there's no subscript, no coefficient, so I should have 1. For H, there's a subscript of 4, no coefficient, so I should have 4. And then for O, we have 2O2, so the subscript 2 means there's 2 oxygen atoms. Coefficient means there's 2 molecules of that, so there should be 4 oxygen atoms altogether, and that's what we get. And we're going to do the same thing for our product side, what's coming out. So again, identify our elements and pull them out. For C, we're going to look at CO2, and I don't see a subscript or a coefficient, so we have 1. For H, so I have, even though like I have an O here, we're going to line them up to like match our reactant side. That way it's easier to tell if they're balanced or not. So we're going to jump over to the other side and look at H for 2H2O and identify how many atoms we have for H. So I have a subscript 2 and a coefficient of 2, so I'm going to multiply those together and that'll give me 4 H atoms. And then for O, I notice I have 2 O's on this like product equation or formula. So I have O2, which is 2 oxygen atoms, and then I have O in my 2H2O formula. And there's no subscript, but there is a coefficient of 2, so that's 2. And we're going to add those together, and that gives me 4. So if I'm looking at my reactant and product side and comparing, my orange and purple for C both match, they're 1. My orange and purple for H are both 4, and my orange and purple for O are both 4, so this is a balanced equation, and I don't have to do anything further. But what happens if I give you an equation or you come across an equation and it's unbalanced? So this is an example of one that would be unbalanced. So you're going to go through the same steps. You're going to want to look at your reactant and your product sides, pull out your elements, count your atoms, and then you're going to move in and balance those equations. So first we're going to look at our reactant side. So that left side, that's orange. We're going to identify our elements, take an inventory. So I pulled out C, H, and O, and then I'm going to count my atoms. For C, I have a subscript of 3, so I have 3 C atoms. For H, I have a subscript of 8, so I have 8 H atoms. And for O, I have a subscript of 2, So it gives me 2 O atoms. Add them all together and I get 13 total atoms on my reactant side. So that's just taking your inventory, just counting out and seeing how many atoms you have for each element in your reactant side of your equation. You do the same exact thing for your product side again. Identify your elements, take inventory and pull them out. I have C, H, and O, just like my reactant side, so none of that's changed. Count your atoms. For C, I have no subscript or a coefficient, so I have 1. For H, I have a subscript of 2 and no coefficient, so that is 2. And for O, we're going to combine those like terms. So I see one that's O with a subscript of 2, so that's 2, and an O with no subscript, no coefficient, that's 1. Put them together and I get 3. Add them all together and I get 6. So now when I'm looking at the reactant and the product side, you're comparing. I notice my reactant, my orange, and my product, my purple, there's a bunch of things that don't match. So this is an unbalanced equation. My C has 3 on the reactant side. My C has 1 on the product side. My H has 8 on the reactant side. My H has 2 on the product side. My O has 2 on the reactant side, and my O has 3 on the product side, and the total number of atoms aren't even the same, meaning after this chemical reaction, we lost a bunch of atoms. So this is an unbalanced equation. And this is all basically the same stuff we've been doing up until this point. So now you're going to take it a step further and you're going to work on balancing the equation so that it is balanced. So, but to do this, you're going to change the coefficient. You're never going to change the subscript ever. So don't ever like change the number for the subscript. That's actually going to change the substance of that like compound or molecule. So only change the coefficient because that's just adding or changing the number of molecules. So you're not actually changing the substance, just the number of molecules. So to do that, we're going to, again, take inventory of our equation, pull out our elements, and count our atoms for both the reactant and the product side. Basically what we've been doing. Now you're going to look at your equation and you're going to add your coefficient to try and get them to match. So what I'm going to do first is I'm going to look at C. On my reactant side it's 3 and my product side it's 1. So the easiest way for me, I think, to make this more balanced would be to look at my product side, the 1, and try to get it to match the 3. So to do that, I can easily put a 3 coefficient in front of the CO2 on my product side. So I'm going to go ahead and do that. And when you do that, it's going to change the total number of atoms. So you're going to recount. So putting a 3 in front of 3 CO2 is going to change my 1 to a 3. So now my C's match on my product and my reactant side. But notice that you're changing the whole like formula there. So it also applies to your oxygen atom that's in that formula. So now I have to go down on my product side to my oxygen atom and then change that number too. So I had a subscript 2 that was 2 originally. And I'm going to multiply that by 3, and that gives me 6. And then I'm going to add that extra O that's in the H2O. And I'm going to have a total of 7 oxygen atoms. So the only thing right now that I see that's balanced is my C's, so I still have a little bit of work to do. So the next thing I'm going to do is going to balance those O's. Let's see. I'm going to do that by adding a 4 in front of my 4H2O. And this is going to do a couple things for me. It's going to, 1, change my H's. I have a subscript 2 here on my product side, and then now I have a coefficient of 4. So multiply those out, and I have 8. Because that O is part of that formula there, the oxygen, you're gonna have to apply that there. So I have no subscript, but a coefficient of 4. So I have 4 oxygen atoms on that side of that formula. But I also have to include the other one that is also changed. So I have subscript 2 there, times that by 3, and that's 6. You add those 2 O's together, and you get a new total of 10. So looking at my equation again, I'm going to see what I have so far. My C's match, now my H's match, and my O's, my oxygens, still don't match. So I notice on my reactant side, my O is lower than my product side, which is 10. So I'm going to now look at my reactant side and see if I can put a coefficient in front of the O to make it match the total number on my product side. So on my reactant side, the orange side, I have a subscript of 2 and I have 2 oxygen atoms. An easy way to make that 10 is to put a 5 the number 5 as its coefficient. So I'm going to do that. So now I can do a 2 times 5 for my oxygen atom and change the total number of atoms for oxygen to 10. So now if you look and compare your equation, I have 3 carbon atoms on both sides, 8 hydrogen atoms on both sides, and 10 oxygen atoms on both sides. So I'm going to total those up. And on my reactant side, I have 21 atoms. And on my product side, I have 21 atoms. This is now a balanced equation. So some steps to help you balance the chemical equations. There are 5 simple steps. Make sure you, 1, write out your chemical equation and be sure to include your reactants and products. Once it's written, you're not going to change that equation. 2, you're going to take inventory, so count the number of atoms for both the reactant and product sides, so what we've been practicing. 3, you're going to compare the atoms for each element on the reactant and product side. If they're the same in your equation, if they're same on both sides, then your equation's balanced. And if they're not, then you need to do steps 4 and 5, so going into balancing that equation. So step 4 is to look at your equation. Decide where you need to place the new coefficient so your reactant side, the left side, matches your product side, the right. Pick an element that needs to be balanced so that both sides match and add your coefficient there. So making sure that the product and reactant side both have the same number of atoms. And you're just going to keep adjusting your coefficients until both sides of your equation and all the atoms on both sides are the same. Last, you're going to check your balanced equation. Always check your work. So check and make sure the number of atoms are the same. If they're the same, it's balanced. Make sure your coefficients are at the lowest possible whole number ratio. So you don't want to have like a coefficient of like 1.5 or 1.5. It's kind of odd to say that you have 1.5 molecules. So make sure that it's the lowest whole number ratio. So we're going to do one more together. So this is a good time to pause the video, see if you can figure out how to balance this equation. So I've already pulled out the elements for you. The next step would be to take your inventory and count the atoms for both your reactant side and your product side. This is going to be an unbalanced equation. So the next step after that is to start adding and changing your coefficients to make the reactant and product side have the same number of atoms for each element. So take a moment, pause the video, and see if you can work that out. Okay, so we're back and we're going to check your work. So right now I have the chemical equation AgNO3 plus H2S is going to yield us a product of Ag2S plus 2HNO3. So we've pulled out our elements for both our reactant and product side, and we're going to count our atoms. So on our reactant side, the things that we're putting in, I have 1 Ag, 1 N, 3 O's, 2 H's, and 1 S. So just looking at your subscripts and coefficients, counting your atoms like we've been doing. Do the same thing for your product side. After you total your atoms, we have a total of 8 atoms on our reactants. Do the same for your product. I have 2 Ag's, 2 N's, 6 O's, 2 H, and 1 S, giving me a total of 13. So the total number of atoms on my product and reactant side don't match. After the chemical reaction had occurred, I had gained a bunch of atoms, which, because of that law of conservation of mass, shouldn't be happening. So now I have to balance this equation to make sure that I'm not gaining or losing any atoms. So next you're going to make sure that, or check the ones that are the same. So look for any elements that have the same number of atoms. So I notice my H has both 2 on my reactant and on my product, and my S has 1 on my reactant and 1 on my product. So the only elements I need to balance out are Ag, N, and O. If you noticed while I was rating my product elements, I kind of arranged them so they match the same order as I had written on my reactant side. That just makes it easier for me to compare the number of atoms when a chemical equation is very long. You do not have to do that, but I find it very helpful. So let's look at Ag. I have 1 on my reactant side, the orange side, and 2 on my product side. So an odd number on my reactant, an even number on my product. The easiest way to balance that out is to make my odd number an even number. And I can easily do that by putting a number 2 coefficient in front of my chemical formula AgNO3. So I'm going to go ahead and do that. And when I do that, I'm going to be able to change my total atoms for this formula. So for Ag, instead of 1, I now have 2. Now that balances out with my Ag and my product side. But because it's part of a formula AgNO3, that coefficient's also going to affect the number of atoms for N and for O. So apply it to your N. So instead of 1 atom for N, I now have 2 because there's no subscript, but I have a coefficient of 2. So scratch that out, put 2. And for O, I have a subscript 3 atoms, and I'm going to multiply that by 2. So I need to change my O to 6 because 2 times 3 is 6. And I didn't have to do anything for H or S. So this was a fairly simple one because now if I check my reactant and my product side, my reactant Ag has 2, my product Ag has 2, my reactant N has 2, my product N has 2, my reactant O has 6, and my product O has 6. And if I recount the total number of atoms for both sides, I have 13 on my reactant side and 13 for my product. So why can't we, Ms. Harrington, just change the subscripts? So if you remember, a coefficient is telling you the number of molecules there are for that substance. Subscripts tell you how many atoms there are for the substance. So in this image, we have an equation H2 plus O2 yields a product of H2O, so a water molecule. That original equation is not a balanced equation. So the first two are incorrectly balanced. They changed the subscripts. So H2 plus O2 yielding a product of H2O plus O gave me a water molecule and then just 1 oxygen atom, which isn't the same as my original equation, which was an H2O molecule. So I want to keep the substances the same. The next one, they did H2O2, and that did not give me a water molecule, but it does have the same number of atoms for each element for both the example A and example B, but the molecule or the substance that was that became the product is not the same as the water molecule in my original equation. Now, if I just put a coefficient in front of the formula, H2, it's just going to tell me there's 2 water molecules. So the molecule itself stays the same, so the substance is the same, and I'm not changing it by changing the coefficient. The coefficient is just giving me an extra water molecule. So that's staying true to that original equation. So when you change the coefficient, you're not changing the substance at all. But when you change the subscripts, you do. So that's why we never ever change the subscripts when we're balancing our chemical equations. Now, for homework, I only gave you 2 practice problems. So you want to balance these 2 chemical equations so that they are the same number of atoms for each element on your reactant and your product side. So number 1 is Al plus N2. That's my reactants yielding a product of 2AlN. And for that Al, that's a lowercase l, not an uppercase I. The second equation is FeO3 plus H2. Those are my reactants, yielding a product of 2Fe plus 3H2O. So those 2 problems need to be done as your homework, and we will be doing them tomorrow after our warm-ups in class. So if you have any questions, shoot me an email. I'll try my best to help you. Other than that, I will see you tomorrow.